second. As you can see, the meeting is going to be recorded today. All right, I'm just going to get started here quickly and then we'll pass it over to ACAP. So welcome everyone to the first installment of the 2022 Winter Speaker Series. My name is Jane Burchell and I'm a board member of Sustainable Saint John, and I'm here today with Roxanne MacKinnon and Shauna Sands from ACAP Saint John. Before we get started, I would like to acknowledge that while we meet today on a virtual platform, I'm in New Brunswick, which is situated in the traditional unceded territory of the Wolastoqey, Mi'kmaq, and Passamaquoddy peoples. Today, we're going to be learning about ACAP's microplastic research in the Saint John Harbour. Roxanne MacKinnon, who is with us here, is the Executive Director of ACAP Saint John and oversees an amazing team that strives to create meaningful environmental change in our region. Shauna is the Conservation Coordinator at ACAP Saint John, and she is really passionate about marine biology and wildlife conservation. A few housekeeping items before we get started. Please ensure your video and microphone are off for the entire presentation, and we will be recording this to upload to YouTube later on. If you have any questions, please use the chat window and we will address them at the end of the presentation. And we would ask that the chat window is just used for questions only. And finally, we would like to give a huge thank you to our sponsors, Port Saint John and Commercial Properties Limited. Their support is crucial to the work we do here at Sustainable Saint John. So take it away, Roxanne and Shauna.
Awesome. Thanks so much, Jane. First, I'd like to thank Sustainable Saint John and Jane for inviting us to give this talk. So I'm going to give a brief little overview of ACAP, and then I'll hand it over to Shauna, who coordinates the microplastic projects, and she'll give you way more details. So just want to switch the slide, Shauna. So hopefully everyone here has heard of ACAP Saint John, but if you haven't, we're an environmental nonprofit here in this city. We were founded in 1992 as part of an Environment Climate Change Canada project and have since become a registered charity. And we work with a whole slew of people from business and industry to stakeholders to the city, to our funders in the federal and provincial government. And most importantly, we try to work with and for the community of the Greater Saint John area. So you want to switch slides, Shauna? So the things that we do are basically anything and everything under the environmental umbrella. So we do everything from climate change research to fish community monitoring to community tree plantings and cleanups to water quality monitoring, and everything and anything you can kind of think of, we have either done or are currently doing. So we're really in the environmental world trying to help restore, protect, and enhance the environment of the Greater Saint John area. So we work everywhere between the city of Saint John, Grand Bay, Westfield, Coos-Pamsis, Rothsay, and then the inner Bay of Fundy streams along the coast to St. Martin. So that's kind of our geographical area, which is pretty big, and we get to do lots of fun and exciting things, like this new microplastics project that Shauna is going to kind of give you an overview of and give you a little chance to help participate in the project. So I'll hand it over to Shauna.
Hey, thanks, Roxanne. So on our agenda today, we're just going to talk about why do we care about plastic waste and what does that mean? What are microplastics? What current research is being done by ACAP, as well as ways that you could participate in our current research. Perfect. So first, we'll just give a little history about plastic production. So on the left here, you can see a picture of Life magazine. This was on their cover. This was kind of them celebrating the production of takeaway containers. So they were very excited. They didn't have to do any more dishes or a lot less dishes, but little did they know what impact this was going to have on our planet. So as you can see in the 1950s, they really started producing those plastics, and by 2017, so yeah, 2017, that is now we're up to 400 million tons of plastic production every single year. So that's quite a lot of plastic. Why do we care about plastic waste? So in Canada, we throw away about 3 million tons of plastic every single year. And as well, about 640,000 tons of abandoned, lost, or discarded fishing gear enters our ocean. And that doesn't break down over time. So it could stay there for up to 600 years. About a third of the plastic that we use today is single-use or short-lived plastic packaging. So that would be your chip bags and your styrofoam containers and that sort of thing. And this stat might change now because of the ban of plastic bags. However, this was in 2019. We were still using about 15 billion plastic bags every single year, and close to 57 million straws were used daily. And globally, about 1 truckload of plastic enters our ocean every single minute. And every year, millions of birds and marine mammals worldwide are injured or die because they mistake plastic for food or become entangled. I should have maybe made a little note at the beginning, but this presentation might not be the happiest presentation, so take that with a grain of salt, but there will be ways that we can reduce our plastic production at the home level. So also you've definitely seen these photos around of birds dying and their gut intake of just being all plastic, and same as whales. So these are your macroplastics that you're seeing. These aren't actually microplastics. So macroplastics are actually large pieces of plastics that you can see, whereas microplastics are the smaller pieces of plastic. So we all know that there's definitely ways that we can reduce our macroplastics, and that's, I'm not going to sit here and talk about you got to use your reusable bag, you got to use your reusable water bottle and that sort of thing, and stop littering. But ways that you can impact our society is volunteering in a cleanup. So we at ACAP, we do a lot of community cleanups throughout the springtime, a lot of beach cleanups, and look out for those in the spring. Hopefully with COVID restrictions, we can still continue to do those cleanups every single spring. As well as just be more cautious about when you're going to the grocery store. Do you really need to put your one little green pepper in a plastic bag, or is that something that you can just leave in your cart and wash when you get home? Just being more cautious about the amount of plastic that you're using on a daily basis. So the journey of marine plastics, so it wasn't even really first discovered until 1972. So that's when they really started looking for marine plastic in our oceans. And it wasn't until 1986 that we've actually began collecting that plastic in the ocean and counting the small pieces of plastics that they found. And in 1996 was when the Great Pacific Garbage Patch was discovered. So for those who don't know, it's actually a collection of garbage and marine debris that gets collected in a very large patch in the North Pacific Ocean. And it just sits at the surface of the water, and it looks like a cloudy soup. So it's not your pristine waters, it's more like cloudy looking, as well as it's just full of plastic. And it wasn't even until 2004 that that term microplastics was created. So it's quite relatively new in that sense. And today, researchers are estimating that there's about 15 to 51 trillion pieces of microplastics floating in our ocean surface. They've also been discovered at all of the poles of the equator and all in the deepest part of the oceans, in the Arctic Sea, and all of the levels of our food web. So what are microplastics? So like I said, microplastics are those small pieces of plastics that we do need to see usually with a microscope. So they have to be anything less than 5 millimeters in size. And they come from different sources. They come from runoff. They also come from our clothes. They come from microbeads in different hygiene products. They come from fishing equipment and beach littering. And like I had already mentioned before, a lot of this plastic can be confused by animals and ingested. So they think it's food, but it's actually plastics. So here's a little diagram of how those big pieces of plastics break down into microplastics. So as you can see here, the picture on the left top hand corner, that's a straw, and over time that'll break down due to the waves. Let's say if it was on the beach, due to the waves of the ocean, the rocks, as well as the sun, it just eventually will break it down into smaller and smaller pieces until it's 5 millimeters or less in length. And then once they get that size, they're actually almost impossible to remove from our oceans. So there's different types of microplastics. So there's 5 types. So there's your fragments, which are the smaller pieces of those larger pieces of plastic. So that straw, for example, that would be a fragment. We have our fibers, which are your most common type of plastic. So those are like pieces from our clothing. You'll see later on in our results that we actually have it broken down into microfibers and threads. So your threads are actually from fishing gear, and your microfibers are from our clothes. We also have foam, which are pieces of food containers. So that would be like your styrofoam. We have nurdles, which are plastic pellets, usually from industrial waste. So that would be anything that might be discharged from the pulp mill or that sort of thing. And then we also have micro beads, which are, they are banned now in Canada, but they can still be found in our oceans, and they're not actually banned across the globe yet. So they can still be found in some samples. And then you'll also see later on that we have a category called film, and that would be your plastic bags. So what do microplastics have to do with our aquatic organisms? So we do know that aquatic organisms on every trophic level have been exposed to microplastics because they have been found in all the trophic levels of our ocean. But we're still not really sure what those health risks might be. And that's because different plastic types, there's different plastic shapes, and there's different plastic sizes, and the different species out there, we're just really not sure how that might affect species on an individual level. We do know that if they are to ingest pieces of microplastics, that it could impact their biochemical or physiological process of many different types of animals. And microplastics can expose organisms to potential harmful chemicals like plastics, especially plastic additives like flame retardants, plasticizers, or dyes. So we know that plastics themselves are not a natural component to our environment. So anything unnatural would probably pose a risk. Like I mentioned before, microplastics is such a new term. It's only really been looked at in the last 20 years or so. So we really don't know what the effects are going to be. That is something that we're actively looking at. And that's the same with humans. There's limited information right now on the human health effects of plastics. And that's because, like I said, it's so new. And right now, the research is not uniform. So we're not able to compare the results across the board. So right now, more research does need to be needed. And there's no real clear study because right now, those research is not comparable. So how do we even collect microplastics? So we need to standardize the methods, and that's the main thing that needs to go on. So here in Atlantic Canada, we've all been sort of doing the same method. So we're able to compare our research across the Atlantic provinces. So what we use is we use this big, large trawl here on the left, and that's for surface water samples. So we trawl that across the top of the surface of the water, and all of the microplastics will feed through the trawl and get collected down at the bottom. And then we take our water samples and we look at them through a microscope, or some of us have very larger funds in our research, and they're able to use FTIR imagery, which actually uses chemical ID methods to recognize, count, identify, and classify plastics by their sizes. That's a very expensive tool, and there is one of those at Dalhousie University. So depending on the amount of funding that some researchers might have, they're able to use that technology. Otherwise, microscopes can be done to analyze your samples. It just takes a lot longer, and you need to be trained at a much different level, which here at ACAP, we're actually not trained to do that. So we have sent our samples in the past away to be analyzed. So in 2018, this was the first time we started collecting microplastic samples in the harbor. And that project was part of a larger project with Coin Atlantic over in Nova Scotia. And it was funded through the Environment and Climate Change Canada's, I think it was AEI project. And we went out with Port Saint John. We used a research vessel, and we trawled both in the inner harbor and in the outer harbor of the Saint John Harbour and looked at surface water samples. In order to get enough sample of plastic, we had to trawl for 120 minutes in both areas. So we went out in November. It was very, very cold, but that was a video of our trawl in action. So these pictures here just really show you what we had to dress like because it was November. We went out it was snowing at some of the points, but we had to make sure that we were wearing as much natural clothing as possible. So as you can see, our jackets were not wool, a natural fiber. They were actually plastic. So we had to send our way pieces of thread from all of our clothing because we were likely contaminating our own sample. So once we trawled the big trawl at the surface of the water, all of the water was going to get collected at the bottom. And as you can see the picture here on the right, that was us making sure we sprayed down the trawl to get every single last piece of plastic. So these were some of the things you can see from our sample. So the picture on the left, that was a large piece of plastic. That would be a piece of macroplastic. And that's a piece of a cable ferry tie that we found, as well as the picture on the right, you can see visible blue thread. So that's likely fishing thread that we found. We had to make sure that we even sprayed off every single piece of seaweed that we found as well, because there was probably small pieces of plastic on those. So we sent those samples away to MUN University over in Newfoundland, and they sent us back the results. So here's just some examples of what our samples looked like under the microscope. So these are pictures of microfibers. And then this here is what we found. So we have results from both the inner harbor and the outer harbor. And in both of our samples, we found that microfibers were the most prominent pieces of microplastics. We also found lots of threads, fragments, and foams in both the inner and the outer harbor. So it is important to note that we didn't find any microbeads or any nurdles, so those industrial pieces of plastics. So we took our results and we calculated the density of the microplastics that we found in both the inner and the outer harbor. So in order to do that, we took the sum of the inner and outer harbor samples, and we divided that by the total surface area that we trawled. So if you take those numbers and you compare them to similar studies that were done across the world, we actually have similarly low amounts of plastic compared to others, which we thought was quite interesting considering we have a very high level of industry here in Saint John. But when we looked further into it, we do have a very small population in Saint John compared to larger cities. So that's likely the reason why our samples were a lot lower. However, it should be noted that any sort of density of plastic found in our ocean is not natural, and it is something that we should be looking into at a larger scale. So what is being done in Canada? So like I mentioned before, microbeads, the sale of microbeads, we cannot sell that here in Canada anymore. So anything from toothpaste to face washes, you won't find those little pieces of plastic in them anymore. However, like I said, it's not banned across the world yet. So places like China are still selling these products. As well as Canada is banning the use of plastic bags at the grocery store, as well as they will likely phase out the rest. So those plastic cutlery and those straws, I think they had a pretty large target to have it done by 2021. I think you'll slowly see a difference, but I know a lot of restaurants have already started to stop using plastic cutlery, and you'll see a lot more change in the next few years. So related work that's being done in Atlantic Canada. So Coastal Action is an organization very similar to us over in Lunenburg, Nova Scotia. And in 2017 to 2020, they actually looked at different surface water samples in different areas within Newfoundland and Nova Scotia. And this is some of their results. So where we found microfibers to be the most prominent microplastic in our inner and outer harbor, they actually found that fragments were the most prominent pieces of microplastics. So like I said, this is very preliminary research. So what we did is we actually partnered with Coastal Action for our research that's ongoing right now. So they're the lead on this project, where we're going to be looking at the quality or the quantity and impact of microplastics in the Gulf of Saint John and the Gulf of St. Lawrence and the Saint John River watershed. So we're collecting all the samples here in the Saint John River, and they'll also be collecting some samples in PEI as well. So we went out this summer instead of in the winter, and we started collecting our samples. So again, we teamed up with Port Saint John, and they allowed us to use their vessel. So these pictures here on the right, we looked at the Digby Ferry Terminal area as well as Redhead. And so we did a surface trials there. And then we also did a trial along the Kennebecasis River. And we chose these sites because they were very close to, they had access to beaches where blue mussels could be found. So there's also another researcher on this project, Krista Beardy from the University of New Brunswick. She's looking at the gut content of blue mussels to see the levels of microplastics that are in their bellies. So as you can see, the picture on the right top hand corner, that we went in through some sludgy area. So it'll be interesting to see what sort of microplastics they find in there. So something new that we're doing with this project is we're actually looking at sediment samples as well. So these are being done on the same beaches as those blue mussels have been collected. So this is a very simple process. All you do is you take a 1 by 1 meter quadrant, and you take the surface of the sand and you put that in a bucket, swirl it around with some water, and all of the plastics will actually float to the top, and all the organics, so those rocks, will sink to the bottom. So you're able to filter out all the plastics that are at the top of the surface of the water. So again, we're going to send those microplastic samples away because we don't have the means here at ACAP to do the analysis. So as for our results, we don't have those yet. They're actually in the process of being analyzed right now. So you'll have to stay tuned for those. Hopefully we'll get them back, I would say by, hopefully by the spring, because we are heading out again in this field season to collect some more samples. Those sites haven't been determined yet. So what does this all mean? So we know from our 2018 results that microfibers were the most commonly found microplastics in our harbor. But where do these fibers come from? So we know that synthetic fibers are released from our clothing during a regular laundry cycle. So if we all just want to take a moment to look at the tags on our clothes to see what our clothing are made out of. I didn't do that this morning, but it is 100% polyester. So that is not a natural fiber, that's synthetic. So every time I wash the sweater, it's going to release little tiny pieces of plastic in our waterways. So what does this mean? So we know that it's estimated that 4.8 million tons of synthetic fibers, so polyester and nylon, have entered our water bodies and terrestrial environments since the 1950s, since we really started producing those plastics. And once they're released, they're almost impossible to remove. So instead of trying to remove them, we're actually trying to focus our attention on understanding ways that they're shed, the sources that they're coming from, and their different pathways to the environment, and ways that we can maybe capture those plastics before they actually even enter our environment. And we know that laundry textiles are one of the main contributors to microfibers into the environment. It's said that during one cycle, about 1,000 to 1 million microfibers are being shed in a single wash. So what can we do? We wash our clothes. Some people do a load every day. Some people do a load every couple days. So we are contributing to the microplastic issue. So ways that we can reduce that is maybe try washing your clothes less often. Do the sniff test. Does it really need to be washed at this time? Wash your clothes in cold water. So there's been studies done that washing your clothes in cold water actually releases less microfibers, or less microfibers are shed at the time than if you were to wash it in hot water. You can insert a filter to your washing machine. So these are the different types that, these are just some of the different types that are out there. So the top two pictures, those are a filter that you can connect to your washing machine, and in the discharge hose of your washing machine will bring the water into the filter and then pour the water out, leaving all the microfibers collected in the actual cup. And then the Cora ball here on the left, that one actually is designed to stop or reduce the shed of microfibers from your clothes. And then the Guppy Friend is a garment bag. So you put your clothes in the garment bag and then you put that into your wash. And then the microfibers that shed off your clothes get collected at the lid of the washing bag, and then you're able to just remove it from there. France will be the first country in 2025 to actually produce new washing machines that have filters in them already that capture microfibers. I think after France does this, you'll see a lot of countries follow through, but that could be quite a ways from now, maybe another 10 years, who knows. But it's also really important to note that plastic microfibers cannot be solved by us alone, and it needs to require changes from across scales and across industries. But at least we can try and help when we can. So as part of a project here at ACAP, we were actually funded through in the Environment and Climate Change Canada's Eco Action Grant, as well as the New Brunswick Environmental Trust Fund, to give away filters, these lint levers, to participants that want to contribute to our research. So these filters are known to actually capture about 65 to 85% of microfibers that come off our clothing. And you only need to clean it about every 2 to 3 weeks or every 10 to 15 loads. So this is what it would look like on your wall. This is my washing machine at home. So all you do is you take your discharge hose from your washing machine and you hook it up to the filter itself, and all of the microfibers get caught in the cylinder there. And then all the clean water goes out through your other discharge hose. So at my house, every time I do a wash, I write on the whiteboard, oh, that was wash number 1, until I get to about 15. And then I will clean the filter. We are at my house, we're a household of 2. So it actually took us 5 weeks to get to 15 loads, whereas a family of 4 or 5, it might take them a lot less time to get to those 15 loads. So this is what the filter actually looks like when it is time to clean. So you can tell it's very visibly has lots of microplastics or a lot of lint on it. So what we do is you can either put a coffee filter at the bottom of your sink, so you're not letting any of the microfibers go down into the sink, because that would defeat the whole purpose. Or what we do is we actually use sort of like a colander almost, and we pour all of the water and the discharge from the lint lever onto that, and then we just clean it with a piece of paper towel. And then what we're hoping for people to do is actually weigh their lint afterwards, and they'll give us the amount of lint that they've removed from their filter, and then we're able to quantify how much weight in microfibers is being removed from our waterways. So here's a way that you guys can get involved with citizen science. If you were interested in receiving a lint lever at all for your home, or even research or helping us with our research, we are looking for participants to help with that. So if you want to write down my email address, I'd be happy to provide you with a lint lever. And this research is about a year long, so you would only really need to help us for about a year. So all you would do, if you did clean out your lint lever, you would dry your lint. So we do want a weight of dry, not wet. And then we were going to provide you as well with a scale, and then you would weigh your lint. And then that is how much plastic you've removed from our waterways. And then you would go onto our website, and you're able to upload your data from there. It's pretty straightforward. The questions you'll see, it just will help us write our final report at the end. So again, this project was funded by Environmental and Climate Change Canada, as well as the New Brunswick Environmental Trust Fund. And if anybody has any questions, I'd be willing to answer them for you.
Awesome. Thank you guys so much for that presentation. I'm definitely into doing less laundry, so I'll definitely be participating in that aspect and hopefully picking up one of the little gadgets you talked about. We do have one question here in the chat about macroplastics. What can be done about hospital wastes? Every mask comes in a plastic Ziploc. So they're just kind of wondering about that, if you have any insight.
I feel like because the hospital needs to be a sterile environment to begin with, that's one of those, I wouldn't say touchy subjects, but one of those areas where you almost have to just let the hospital do what the hospital does. But in terms of masks and the pollution that masks are creating, just be more mindful of your masks. And when you are discarding them, hopefully you're discarding them in the landfill or in your garbage at home and not on the streets. And it's important to actually cut the strings on your masks, because if they are ending up on our streets, it's likely that animals can get caught up in the strings as well. So just be more mindful of your masks that way.
Yeah, some great advice. We have another question here. Do we have an issue with fibers from tumble dryers?
So all of your dryer lint should get caught in your dryer lint discard thing. So it's really important to discard that into your garbage rather than just letting it. I know some people actually use it for the birds, and they think they might want them for nests, but don't do that, because that's just plastic being entered into our environment.
Awesome. Okay, we have another question here. Have you tried using smaller mesh sizes for collection of samples? I know that some studies have shown trawls can underestimate small plastic particles.
That's a great question. We designed this project based off of what Coastal Action, and they also designed their project on what Mun University was doing as well. So that way, if we all use the same size mesh size for our trawl, then we're able to compare our studies in the end. I think it was 333 micron size is our mesh size. So it's really, really, really tiny. But I think they even go smaller than that, like you said. So yeah, it's probably very likely that we're losing microplastics every time we trawl.
Yeah, but when you think about how small they can be, it's definitely a challenge. All right, we have another question here. For the microplastics coming from laundry, would they stay in your septic tank or pass through the septic field? And if they are passed through, how do microplastics affect the soil health?
Yes, so that's another question that we're hoping to gather from people that do this study. So I know I'm on a septic tank, so that doesn't necessarily get discharged into the city's water system. However, it is been proven that microplastics do seep into our groundwater and then eventually get kind of thrown around in our environment. So we haven't looked at soil samples here yet, but it would be interesting actually to see if the people that are on septic, how much microplastics might be in their soils on their land. And like microplastics, again, is such a new topic that it's just expanding all the time. So we're hoping that once we do receive this information from our citizen science project, that we can build upon that and apply for different grants. And maybe that is something that we look into.
Awesome. All right, another question here. Will microplastics in the ocean ever completely break down, or will we have them forever?
I think we'll just have them forever.
Yeah, I think your slide at the beginning there said 600 years,
Mm-hmm.
which I guess is forever.
Yeah. I mean, they will kind of dissipate in the sense that they do get trapped in the Great Pacific Ocean rather than here in the Bay of Fundy, because there's so much current. So I guess we're lucky in that sense that we might have less than the North Pacific garbage patch.
All right. What are the chances of having a campaign to ban man-made fibers for clothing? We have campaigns against animal fur.
Oh, that's a great question. I don't know. I think that would be way harder than expected, just because plastic is so cheap to make. Even natural fiber clothing, so your cotton and your wool, that's still going to shed, and it's still going to go into our environment. And the amount of that is still way more than our natural environment has. So, and it's full of dyes as well. So
Yeah.
You almost just need to stop wearing clothing, which I know it's not going to happen, but
Stop buying clothing, buy secondhand.
Yes.
The tips for sure. And then we have a volunteer here, actually my colleague here at Port Saint John, and she says, if you do a soil study of septic fields, I would be interested. So we have some willing participants already.
Excellent. Yeah, well, we'll be doing probably another round of grant writing here soon. So that'll be something that we definitely keep in mind, because I think that would be a really interesting study to do.
For sure. All right, we have one last question here. Could you comment if there is any difference in the sample analysis methods used during 2018 research versus the current research?
We're doing the same methods. The only thing that's different for us is we are collecting those sediment samples. And so we don't know what those results are yet. And then in the summer coming up, we're hoping to do more inner river studies. So we're hoping to actually go up towards the upper Kennebecasis River and maybe do some samples towards farming industry to see what sort of agriculture plastic waste is being produced. So that'll be different, but method-wise, it's all the same.
Awesome. Okay. Well, thank you guys so much today for coming in. It's been really informative for us, and we look forward to hearing kind of where your research goes after this. Maybe another lunch and learn in the future.
Yes. Well, thank you so much.
Awesome. Have a great day, everybody.